Welcome, everyone. For today's prep, we're going to look at infinite limits. And we've seen this idea before when we were kind of doing limits graphically and numerically. And today we're going to see where these show up algebraically. And they show up with what we call the C over 0 form, which we'll see in a few minutes. All right, so let's just recall. What does a infinite limit look like graphically? And here we have a function y equal to g of x. And we've seen this example before. But what we notice is that as our input x moves closer and closer to, well, in this case, the number 2 from either side. So we can approach from the left or we can approach from the right. And what we notice is that the height of our function is getting larger and larger positive. So on either side, our function is going up and up and up. And in this case, we would say that the limit of g of x as x approaches 2 is equal to infinity. And we're using positive infinity here because the height is large positive. So we're moving upwards. So there's a similar notation for large negative. Our graph moves down, and we would use minus infinity. So this is an example of a function that has an infinite limit at x as x approaches 2. And this dotted line here, we'll talk more about this, but we call this line a vertical asymptote. Probably mentioned that we'll look more at this in class. So in this case, our vertical asymptote is the line x equal to 2. So we'll come back to that. All right, so this is what an infinite limit would look like graphically. Now, we've also seen this numerically. So let's just kind of recall what an infinite limit would look like numerically. So when we numerically calculate a limit, we do our table. So we have our input values x. We have the output values of our function, so f of x. And in this case, in this table, we're looking at input values x that are getting closer and closer to the number 1, but from the left. So we're using values that are slightly smaller than the number 1. So what we're doing here is we're calculating the limit of f of x as x approaches 1 from the left. We're using input values that are just slightly smaller than 1, but are getting closer and closer to it. And what we see is that as these input values get closer and closer to the number 1, we look at the output values. And what we see here is that the corresponding output values are getting larger and larger negative. So in this case, we would say that this left-hand limit is minus infinity. And we're using minus infinity here because the outputs are getting large negative. Okay, so graphically, numerically, we've seen infinite limits before. So and we've seen the notation. So positive infinity if the output values are getting large positive, negative infinity if the output values are getting large negative. Now, two comments here. The second one is that technically these limits do not exist, but they're not existing in a very specific way, so we want to be a little bit more precise in our language here. So, technically, this limit does not exist. But infinity, you want to almost think of it as like a place. It's a direction where we're going to. So there is this direction that we're headed off to, which we can kind of specifically describe. So we want to do that. And then going back, the symbol infinity is not a number. So as we kind of work with limits more and more, we're going to be tempted to kind of think of infinity as, just doing regular arithmetic. And it's not a number, so regular arithmetic rules don't always apply. So we just want to think of infinity as a kind of like a place that we're going. All right, so just a little few comments there. So how do we locate where an infinite limit is? And this is kind of taking us more to the algebraic side of things. And usually what we're going to see is these infinite limits most of the time happen when there's division, and specifically when we're trying to divide a non-zero number by 0. So we're trying to divide by 0. So we have this, what we're calling this C over 0 form. And just a comment. The constant C on the top can't be 0. That's going to be something else. So 0 over 0 is an entirely different thing. So right now we're looking at a non-zero number divided by 0. This is a special form, and this is when infinite limits happen, usually. There are other cases, but this is going to be one of the more common types that we see. All right, so what are we going to do? Well, our strategy is first we identify that our limit is this C over 0 form. So we're just going to try direct evaluation. We're just going to try plugging in. That's what this first step is. So we try our direct eval. So our previous strategy for calculating limits, just kind of plug in the number x is approaching, and if you get something that makes sense, good, that's it. In this case, if we try our direct eval, we're going to get some constant divided by 0. So that's going to be our first step. Still, the first step here is try direct evaluation. But the C over 0 form is going to tell us that something's wrong. And specifically what that tells us is that when we do have this C over 0 form, our limit is either going to be plus infinity or minus infinity. So there's only the two choices then. And then the way we figure out which, is it going to be positive or negative, we're going to use what we'll call a test number to figure out if we're kind of looking at positive numbers or negative numbers. So let's try an example. So let's look at the first one here. So we have this function 1 plus x over 4 minus x. And we're going to calculate the limit of this as x approaches 4. And let's start with the first one here. So we're doing the left-hand limit. So x is approaching 4 with values that are slightly smaller. All right, so what's the first step? First step here is we try our direct eval. And we see what we get. So let's plug 4 directly into our function. And if we get a number, good, we're done. We know what the limit is. But in this case, we get 1 plus 4 over 4 minus 4, which is 5 over 0. And what that does is it tells us that's not the answer, but it does tell us that we have a C over 0 form. Okay, so this is a non-zero number, 5, divided by 0. So what that means is there's only two choices, two possibilities for what this limit could be. It's either going to be plus infinity or minus infinity. So that's the second step. And we just have to figure out which it is. So the C over 0 form is telling us that we have an infinite limit here. All right, so we got to decide positive or negative. And the way we do that is with a test number. So that's the third step. We got to use a test number. All right, so, and because we're dealing with a left-hand limit, the idea is we want to pick a number. We can't pick 4 because we know 4 is an issue. We're approaching 4. So for the left-hand limit, we want to pick a number that's close to 4, but slightly smaller. So a good test number in this case would be like 3.9. It's close to 4, but a little bit less. So that's going to be our test number for the left-hand limit. And then the idea is we just plug this in. So we just plug this into our function. So let's do 3.9. We don't have to worry about simplifying it all the way down. We just need to know, is it the result going to be positive or negative? So let's see what we get. So we're going to get 1 plus 3.9 on the top. And then we get 4 minus 3.9 in the bottom. And simplify just a little bit. So we get 4.9 in the top and then positive 0.1 in the denominator. So what we have here is a positive number divided by a positive number. The result is positive. So what that tells us then is our infinite limit is positive infinity. So we would say that this limit is positive infinity. All right, and that's the idea. So for kind of doing these limits algebraically, we want to first identify that we actually do have a C over 0 form. Then the second step is just to recognize what that form tells us. So we have an infinite limit then. And then the third step is, well, pick a test number and see if the result is, when you plug that in, is positive or negative. And then that tells you what ultimately the limit's doing, either positive infinity or minus infinity. So let's try the right-hand limit. And so we're doing the left-hand limit. We did the left-hand limit. Now we're going to do the right-hand limit. But the first two steps are going to be exactly the same. So it doesn't matter. If we plug 4 in, we're still going to end up with the C over 0 form. So steps 1 and 2 are the same. That's not going to change. So we know, in this case, that it's either going to be plus infinity or minus infinity. Those are the only two choices for this limit. So then our next step is a test number. Okay. Now we're dealing with the right-hand limit. So x is approaching 4, but we want to add on a little bit extra. So when we pick our test number, we're going to be close to 4, but let's add a little bit extra, so maybe 4.1. And then we're just going to plug that into our function and see what we get. So when we do that, we get 1 plus 4.1 over 4 minus 4.1. And if we simplify, we end up with 5.1 divided by negative 0.1. And we don't have to worry about simplifying this too much. We just want to keep track. Is the result positive or negative? So in this case, the numerator is positive, but the denominator is negative. So what we end up with here, when we have a positive number divided by a negative number, the result is negative. So that tells us this limit is minus infinity. So our right-hand limit is going to be minus infinity. So, we've done the left-hand limit, and for that, we picked a number that was close to 4, but just a little bit smaller, so subtract a little bit. For the right-hand limit, we picked a number that was close to 4, but we added a little bit extra. And what we're seeing is that the left-hand limit was plus infinity. The right-hand limit was minus infinity. So if we put that together, we can say that the overall limit does not exist. And the reason there is because the left-hand limit is different from the right-hand limit. So they're going in two different directions, essentially, the left and the right side. All right, so we'll practice some more examples of this in class, but just to kind of get us started thinking about division by 0. So we'll see you in class. Bye-bye.